Okay, there we go. Okay, my name is Wai Tai. I'm a solutions architect with the ConfD and device programmability team. So ConfD is TelApp's original product. It's a data model-driven transactional framework that enables devices to be programmable. So TelApp has been working with the equipment vendors directly to help them enable their devices to be programmable and with NetConf and YANG. So I've originally joined TelApp back in 2010 in working in pre-sales, providing support of ConfD and NCS. Back then it was called NCS and it's now called NSO. And my current responsibilities on NetConf and YANG adoption, ConfD, as well as NSO interoperability with NetConf devices. Okay, so here's the agenda. I'm going to be talking about programmability, what it is, and why it's important, and talk about how programmability can be delivered using NetConf and YANG, and how REST API fits in, as well as how programmability should be implemented at every layer of the network. So I have put in a poll question. So okay, it's come up already. So if you can put in that new code. So the question is, what is your familiarity level with NetConf and YANG? So I'll give you a couple of seconds to answer that. Okay, numbers coming in slowly. Well, it looks like the ones that are familiar already are the ones that are quickest to respond, right? Okay, we have about what, I don't know, 70 people here. Okay. Okay, so 3.2. Well, 70. There's still more coming in, but I think roughly, so what, between intermediate and advanced, I assume. Okay, let's move on. Okay, so programmability is the key to automation. So it used to be that in the computer domain, in the compute domain, you have computers and servers that are easily programmable and can be automated. But then when it comes to the networking domain, it's often very difficult. You often require the skill set of a network engineer, as was shown during this morning's keynote by Colin, that sits behind a terminal using CLI to configure one network devices at a time. And that process has been very error-prone, and many human errors can happen during that process. So thanks to SDN, it has brought programmability to the network. Now we can configure and manage the network elements and services using software. So when it comes to configuring and managing large-scale multi-vendor networks, it's often a pain when you have to deal with the different management interfaces that are being offered from the different vendors. So obviously, it creates a lot of overhead from having to write the automation software that have to deal with the differences between the different vendors in management interfaces. So it's really crucial that a common and standards-based method of programmability is being adopted for all of the network equipment vendors. And when we talk about aspects of programmability, it's more than just having an API. API only defines how you configure the system or access information from the system. there are other functionalities that is required to go along with that API. For example, we have AAA, so you have authentication, authorization, and audit log. So you need to control the access of the API, as well as an audit log that shows the kind of access that has happened in the past. And then you need to have transaction support by the API that can ensure that any configuration changes that are being made on the device is consistent in a known good state. So if anything goes wrong, the device should not carry out that transaction. So if the API for that network element does not support transactions, then when you're in the middle of making a configuration change, even programmatically, if anything goes wrong, now it's up to the automation software to have to figure out how to get it back to a known good state. And then it's also just as important to be able to independently perform validation without performing the transaction or without committing the transaction. You need to be able to know ahead of time whether a particular configuration will succeed or not before you push it down onto the device. So benefits of programmability. Since programmability is the basis of automation, these are also benefits of automation. So they include time and money cost savings. So with automation, now you can do things faster. Not just being able to push down configurations onto the device faster, but you can do other things faster as well, right? Because now you have all of the available information available to you that you can pull from the device. And you're also able to turn on, to activate a service much faster when you have automation or programmability available at different layers of the device, of the network. And with automation or with programmability, you reduce the chance of having human errors, because now everything is programmable. Things should be uncovered while the automation software is being developed, as opposed to when you're trying to push the configuration changes down onto the device. So to go along with that, when you have programmable interfaces on the network, the error handling is much more improved now. It used to be the days that when you have to rely on CLI, because you have to do a lot of parsing. So now when something goes wrong, it's very complicated to code into your automation software in order to be able to deal with the errors that happen. And because of the information that's available to you that I mentioned, like all of the operational state data, now you are able to troubleshoot your network issues much quicker. And given all the programmability that's available to you, now you can easily customize any features that you want to see on the network. And then with programmability, now you are able to abstract your network at various different levels. So I'll touch on more about that. And it also enables innovation, right? So things that you may not have thought of just yet when you were defining those APIs, some intelligent or smart programmers out there will figure out how to make the best use of your API. So they will be able to come up with applications that will make good use of the APIs that is available on the network. So what is programmability? So SDN is what brought programmability to the network. So it used to be that you rely on EMS and NMSs in order to be able to configure. Usually it's the same vendor that comes up with their own EMS or NMS that can be used to configure their own devices. And a lot of times, a lot of the intricacies of the device attributes themselves are being exposed to the end user. And it's really unnecessary. But now, given the advantages of the benefits that SBN brought to the network domain, now all of those things are being abstracted out. Now you rely on controllers and service orchestrators in order to work on the various different layers. So SDN identified the network layer that allows you to view the entire network as an abstraction layer. That way, if you're working at that layer, you don't even need to know what type of devices are on the network. And then there's also the service layer. That's where products such as our NSO plays, that exposes the service layer into a abstracted YANG data model. So now network elements are being programmed as opposed to manually configured, as it was done in the past using CLI. So you have data attributes from your YANG data model that you can program. And network configuration and management becomes an exercise in computer science, right? Just as if you're writing any software programs. So an API. So in order to be able to take advantage of the programmability, you need an API to the network elements, and be able to have a consistent interface across multi-vendor products. You really need to we really need to standardize on a single kind of API that can be widely deployed in the network at the network element layer. So what is an API? So when you work with computer programs, there's usually a API for the library that allows you to figure out how to develop your own software on top of it, how to program the computer. But now when it comes to the networking domain, we have a API that would expose the abstracted view of the network. And the network programmer no longer need to know the unnecessary details when they are trying to program the network. So the API provides a specification of what data is available. So these are like attributes, right? Since most of you, or maybe all of you, are already familiar with NETCONF and YANG. So it's like setting a particular leaf node attributes, right, to a particular value. So that is what kind of data is available. And then how the data is organized. So this refers to data structures when you're writing computer programs, or schema if you're familiar with the database domain. So in the case of YANG, then the schema will be derived from YANG. And then how the data is accessed. So this is like a method call, right? Or a function call when you're writing computer programs. Question? Oh, I'm sorry. Okay. Okay, sure. So, for example, as I mentioned, well, in the more traditional EMS and NMS domain, a lot of the device attributes that are being made available to you may be very specific to that particular implementation from that vendor. So if you have an API that abstracts out those maybe very specific to that hardware implementation hidden, now you're only working on things that are necessary to configure a particular networking service. Then all those things will be hidden from you. And another example would be if you are working at the service layer of NSO, Now you no longer need to know about the device attributes. You are defining, okay, you want to go from point A to point B, and what kind of service you want to have. You don't have to say, okay, I want a particular device attributes from a particular node on the network to be set to certain value. So that's all disappear from the network, if you have an API. Thanks for the question. So NetConf and YANG. So NetConf is a IETF standard protocol. It uses client-server RPCs, or remote procedure calls. So think function calls or methods, right? When you are writing a program, you need to know what method calls are available to you, or what RPCs are available to you when you're working with a network element or device. And NetConf is transactional. So I believe, as someone had alluded to earlier this morning from the audience, that NetConf is, I believe at this moment, is the best protocol out there available for interacting with networking elements or network elements, because it's transactional. So it ensures that configurations will always result in a consistent good, known good state. If anything goes wrong, the device will always reject the transaction, and it will restore back to its previous state. So now this is really simple for automation software in order to be able to configure devices on a network. That was a question? Which company? Oh, RBUs, yes. Well, yeah, Cisco's have been pushing hard on NetConf and YANG. In fact, I believe in some of the presentations that we showed earlier, we already have products such as XE and XR. Those are already support NetConf and YANG. No, those already support NetConf and YANG, and I'm sure there's some migration period that eventually. You mean all the Cisco products, or? Right. So I'm saying, so some of the bigger Cisco products, the bigger routers, those are already supporting it, and there are a lot of other smaller products supporting it already too. Yes, there's a big push towards that. And then YANG is a complementary data modeling language that works alongside with NetConf. It defines configuration data, operational state data, and actions. And it's being used to define the structure and constraints of the data. So together, NetConf and YANG deliver a standards-based API. They include the methods, the attributes, and the data schema. So one of the biggest benefits of adopting NetConf and YANG as it applies to NSO is that you no longer need a custom net to be developed. So it obviously saves time and money, and it will allow your service to be able to be activated much sooner, and certainly it would help you to generate revenue much quicker as well. Okay, so since most of you are familiar already, I'll just quickly go through this YANG example. So if you look at the YANG data model snippet that is shown on the left-hand side, and see and contrast how that represents the XML equivalent on the right-hand side, you can easily see how things are being mapped, because XML is being used to carry the paid load over NetConf. So the list, so you have the interfaces container, and then the list interface. So all of those being turned into XML blocks, and then the leaf nodes are the one that encloses actual attributes. And it's important to point out that you see the must statement up there. This is a way to enforce constraints within your data model, right? These are constraints relationships between various different pieces of your data model. So they will be enforced at runtime. So this really simplifies the amount of error handling code that you need to do when you are writing or building your automation software. Then this is just the actual NetConf command and response, the RPC commands, as well as the response. So you see that how the edit config request going to the candidate data store is coming down, and then how you get the OK RPC replies. And one of the things that I didn't touch on when I talked about the API specification, I mean, the other great benefit of having API is that you can have well-defined error codes, right? So now if anything goes wrong at the programming time, at the development time, now you can write code to handle those errors nicely. So standardized YANG data models. So use of standard-based YANG data models, so obviously would increase the commonality of the API across a heterogeneous multi-vendor network. So if you think in terms of NSO, so obviously the device templates will be much simpler. Right now, you can write one set of device templates and be able to use it across multi-vendor products. So now you don't have to build one per device. So there are many organizations that are working, that have already defined or working to define standard YANG data models for their particular domain. So they include the IETF, the OpenConfig, IEEE, Metro Ethernet Forum, Broadband Forum, and Open Daylight. So when I talked about the agenda, I mentioned, so why not REST? So it really refers to why not REST for devices. So REST is a set of techniques for using the HTTP protocol. So each vendors may define their REST APIs differently. And it's not a standardized protocol. And it doesn't have a set data modeling language associated with it. So a REST API essentially is proprietary. So it's almost as if you're working with CLI, except that it is a programmable interface, but you have to deal with it on a per implementation basis. So IETF has defined RESTConf, which borrows a lot of the same concepts of NetConf and YANG. And it's try to map them into HTTP verbs in order to turn the REST API as more like NetConf. So that is certainly moving in the right direction. But the standardized mapping, but the issue still is that the RESTConf API is not as powerful as NetConf. There are quite a few features that are missing. So things such as transactions, it only supports a very limited scope of transactions. It has no notion of data stores. You cannot specify which data store that you would like to send the request down to. And then you cannot perform independent validation. So programmability is needed from top to bottom. So in order to be able to easily automate your entire network, you really need it at all the layers as shown in this diagram. So with what SDN has brought to the networking domain, at the service orchestrator and SDN controller layer, they have certainly become a lot more programmable, or they're certainly programmable. But what we've seen is that at the device layer, not everything has been made to be programmable yet. So it's very important to point out that programmability is just as important down at the device layer as it is up at the circuit orchestrator and controller, SDN controller layer. So it's important when you come up with requirements for your equipment vendors that you're sourcing your equipment from, network equipment from, that NetConf and YANG should be demanded as a requirement. So if the only thing that you need to remember from my talk would be that demand NetConf and YANG from your vendors, from your equipment vendors. Okay, so I mentioned ConfD earlier. So ConfD is a complementary product to NSO. It is a very flexible data model-driven transactional framework. It supports a variety of open standards-based interfaces, and it includes NetConf. It uses YANG data models in order to automate runtime processing, and it certainly reduces development effort for developers. And it's an ideal solution for producing programmable network elements for SDN and NFV. And we do have a ConfD basic version available for download, which I will show a couple of links on the last slide. So here's some resources for you. We have our TerrApps website that have information about our products. We have a video tutorial on NetConf and YANG, and it has and I'm showing a link for where you can download ConfD Basic. And then we recently published a white paper, a heavy reading white paper, on enabling network programmability and automation with NetConf and YANG. So I believe we have, 2 minutes maybe for questions? Or maybe not.
Thank you, Wai.
Okay,
thank you for
sure.
your presentation.
Yep, okay.
Here's
Thank you. Okay, thank you.